Thank you all for attending this talk. At the beginning, I'm saying because it's a Saturday afternoon, and welcome to this special seminar by Professor Achyut Ghosh, who is really special. In fact, I'll explain how it came about. He gave a talk on how to be an engineer. I must say, how to be a good engineer. Anybody can be engineer, but a good engineer. That talk he gave in IAST, which is his alma mater, which is the old Bengal Science Engineering College. Now it's called Indian Institute of Engineering, Science and Technology in Shibpur. And that talk was very nice. It taught me a lot of things and also to others, audience in that thing. One slide in that was on engineering standards. That caught my attention, because I've been looking for people who will educate us on engineering standards. Professor Ghosh, who has extensive experience in industry, has a deep understanding of engineering standards. And I think he's the best person to tell us about engineering standards today. Let me just introduce Professor Ghosh and his background. He was born in 1941 in Kolkata. And as I said, he studied in the Bengal.
Professor Ananta Suresh, you should not go through this rigmarole. I think everybody got it through the mail.
Okay. But anyway, let me just do that. He worked at Telco and Metco and Simpark infrastructure and a lot of other things. In Switzerland also, he was considered for some of the bridge designs as well. He's a fellow of Institute of Engineers and fellow of few other places also. Very distinguished industry expert. Also, he has some experience of teaching in colleges. That's why he's Professor Achyut Ghosh as well. He has published 60 papers in various journals and a lot of design experience. Other thing they will see is his wonderful hobby of gardening. He will come to that in his talk, just as it was there in the previous talk. Achyut Ghosh, we are really privileged to have you here today. Please, the floor is yours to tell us about engineering standards. Thank you.
Thank you, sir. And thank to all the listeners. Can you hear me, sir?
Yes, we can hear you.
Right. So I'll come to the presentation in a moment, but I must thank the organizers for kindly permitting me to present in a very august forum like IESS, associated with Indian Institute of Science and IIT Hyderabad, etc. So let me start my presentation. I'll try to enter my screen. Enter. This is one. Okay. Your entire screen. Yes. Here. Which one? No. This one. This one. Mute. No. Huh? Cancel. Mute.
Sir, may I help you in sharing your screen?
Mr. Ghosh, you are muted. Please unmute. Yeah.
Mute and share your entire screen. Is that it?
Yes. Yeah.
Yes. And then which one? I'll click this one.
The present now next to the hand symbol.
Yeah, you have a top arrow, sir. Yeah, can you click on that?
This one?
On the right of the hand symbol. Hand symbol is there. The hand symbol next to that, to the right of it. Present now.
Huh? Eta. Share.
Yeah. Sir. Yeah.
It's coming up. Wonderful. We can see it now.
You can see it now?
Yes.
Okay. So I'll say, how do I change the screen?
So you can click on the PDF file which you have.
Yeah.
Or PowerPoint, whichever.
This is I have to remove. I have to.
Just to shift to that.
Yeah.
Wherever PowerPoint is. Yeah.
Yeah.
while it is opening, you can hide that small things at the thing. You can click on hide.
Yes, sir. Yeah, the pop-up. Yeah.
Hide.
Yes.
Yeah, yes, sir.
Above.
No, don't
No,
click
sir.
that.
Not that.
Sir.
Hide.
Hide.
On the right.
Hide.
There.
Yes,
Yeah.
yeah.
Yeah. Okay. Wonderful. Now you can go to full screen.
Full screen. Yeah.
Yeah.
Full screen.
Yes.
Can you see it now?
Yes,
Yes,
it's
sir.
wonderful. It's clear.
Can you see me also or only?
Yeah, yes, sir. We can see you
Yes.
also.
Oh, that's fine. Oh, I have done it. Thank you. So I called my granddaughter. I mean, these things are very touchy. So I called my granddaughter and she helped me with this. Okay. Now it is 2:40. I hope you will give me 45 minutes.
Yes. Yeah.
So it is 2:40. What I'll do, I'll share my presentation in two parts. One is 30 minutes, which will be on the job itself, the one that engineering standards. And for 15 minutes, there are certain items which I feel an engineer should know. And on these things, these are not connected directly with our engineering standards. On these, I'll spend another 15 minutes. I hope you agree to this. Right. The one that you are seeing on the screen is the Ganga Bridge while it was being constructed. Now it has been opened. And can you see a crane on top? One of my design specialty is such cranes for India. And I have done it on Assam Brahmaputra and for Ganga Bridge. And for Goa, about 11 such cranes I have designed in this country. Okay. Now, our subject is what is engineering standard. Now, this screen will come up with the yellow color on which I'll concentrate. So, the next slide will be on what is engineering standard. Chakraborty Rajagopalachari said, standards are to the industry as culture is to the society. And the photographs that you see in some of the slides are from my garden. I'll come to that in due course. If you don't have any engineering standard, a car will cost millions. You cannot just assemble it. You just cannot assemble it. This will look like a bunch of parts, some gears, some shafts, some splines, clutches, like that. But that does not help you they will not fit with each other. It is only with some codes of engineering standards, that is limits, fits, and tolerances, that we can make this car work. Let us see, this is a car. To the assembler, these are various parts: an engine, a battery, a transmission, an axle, fuel tank, like this. The man who is making fuel tank, he has got no call to know what is an engine. The man who is making the company, it may be in the country of the car manufacturer, or it may be in some other country. They need not know what the car body will look like, what the muffler will look like. They need know this only. This is an engine manufacturer. He knows the engine. To the next man, that is the transmission, you can see the right-hand picture, that he knows about the face to which the clutch will mate and the hole on which the clutch transmission assembly will be aligned. So he knows these two things only, and he knows the space given to him by the car manufacturer. Nothing else he knows. He knows maybe number of gear shifts and all this and all this. So this is how the engineering industry works. Unless there is some standard guiding the people what to expect, nothing will work. You cannot go on giving all manufacturers lot of statements from you that this will look like this will be like this. That will take 5,000 pages at every stage of transfer. That is not a done thing. What is a done thing is we accept one standard, that is limits, fits, and tolerances, and the various codes developed by Indian Standards Institute, that is Bureau of Indian Standards, and then ISO, International Standards Organization, which will come to in due course. So there could be standards on anything, on a soap, on a light, on air conditioning, on a bottle, on anything, on threads. But for our discussion, we'll spend few minutes to limits, fits, and tolerances. This is, you can see how a car part works inside. This, the piston may be made in Italy. The camshaft may be made in Yugoslavia. The gears may be made in India. Like that. But everybody follows a standard and a specification, and the whole assembly works. So we come to Bureau of Indian Standards, who are one of the party responsible for creating standards in our country. On the right, you can see that is in Amsterdam. That is the flower tree of the river of flowers. Anyway, we'll come to Bureau of Indian Standards. We'll spend next few slides on Bureau of Indian Standards. See, the first Indian standard, IS-1, is on our national flag. On the right, you can see. So these are various data in 46 Department of Industry thought about. In 47 January 6, the Indian Standard Institute was started. Mid 1980, IS to BIS, but we go on, and only Bureau of Indian Standards Act in 2016 has been created. Very late, but it doesn't matter. But this Bureau of Indian Standard is a purely Government of India organization. How an IS standard is formulated. This will take a few slides. There is a manual for standards formulation. These manuals talks about the process of standardization, how it is created. I will not read all this, it will take a lot of time. So there is a SAC, Standards Advisory Committee. You can see from the figure that the Bureau is at the top, then the Executive Committee, and there are various parallel committees. But a standard committee consists of about 20 people with various positions like who will be the secretary, who will be the assistant secretary, etc., etc., etc. So that is how any of you, if you are willing to work, you can join, you can request the Bureau of Indian Standards that we want to join this item. There are various groups, SMBC, SMDC, etc., etc., various groups. And as on date, there are about 20,000 Indian standards published. As I said, in various things, it could be on light bulbs, it could be on a pen, it could be on like this, on a pen, like this. Next. We'll show you 3 facsimile of IS standards. One is 1231. It covers the frame of squirrel cage motor, or let us say electric motor. It covers the frame. And the basic thing is this this height, H, height from the base. So the frame is like this. You can see the frame numbers on the left, 90S, 112S. 112 means the height of the center line of from the base is 112 millimeter, but it could be SML. It means it could be, the length will be small, medium, or large. Anybody, any motor manufacturer can accept any of the frame size for output torque, 5 kilowatt, 3.7 kilowatt, 20 kilowatt, but he can use his coating system, and the most efficient design will be highest torque provided at the normal temperature with a minimum frame size. His cost will be minimum. So this is our 1231. Next one, we'll cover one from civil engineering, IS 456. It gives details on what will be the detailing of concrete structures, how the reinforcements are being made, and that kind of thing. And then we have got one ISO 919, IS 919, ISO 236. So that tells you about the system of limits and fits. It's an ISO system of limits and fits. There is another side effect to it. This ISO is a international standards organization. Any country can join it. There are certain obligations, certain rules. About 166 countries has joined. They are free to accept any of the standards published by ISO, or they can print their own standard on the subject if their country standard does not match with it. But India is a signatory of ISO systems, so most of the ISO systems are applicable in our country unless it is specifically negated. So now we'll come to various other organizations producing standards in our country. That is Indian Roads Congress. I must say I am deeply involved in this standardization process, and I am a member of some of the committees, and I work for it. As of now, we are preparing guidelines for the detailing of structures. About 13 engineers and some of them IIT teachers from Chennai, from Kharagpur and other places. They are a member of the team, and I happen to be the convener at the moment for this team. But there are other things, bearings and these, that, and structures. So then there is Indian Railway Standards. Indian Railway Standard by way, they subscribe to IS, but there are certain railway functions which Indians, like the axles, like the bearings, so they prepare the standards and we have to follow. Any supplier of Indian Railways will have to follow this standard. Then there is Bureau of Indian Standards. Then IPSS, Interplant Steel Standards. What happens? Steel industry has got their special demand, like the cranes, like the hooks for the cranes, like couplings, like some of the transmission gears. So these IPSS may accept the Indian standards, or they prepare their own standard over and above. Now you can see some photographs of certain standards. In the middle there is BS, and on the right is IRC, on the left is UN. Standards all over the world. Yeah. So the first is ISO, which is the father's organization of this. And then European norm, European standards in English. They are printed in 5 languages, also known as Euro. Earlier there was BS, British standards, AFNOR, the French, DIN, the German, but now all of them has merged in the form of Euro, and mostly which country's standard is very good on a subject, Euro accepts this. So sometimes they say BS Euro, sometimes they say DIN Euro, like that. We have observed in our work that the British standard and DIN standard, they are mostly selected for our EN, Euro norm. Then in USA, there is ASTO. ASTO is there, AISC is there, then ANSI, API, ASM, ASTM, AWS, FEMA. ASTO is this roads standard. Then AISC is American Institute of Steel Construction. ANSI is American National Structural Institute. API is Petroleum Institute. ASM American American Metals. American Society of Metals, American Society of Testing of Metals, American AWS. Oh, it's a great thing. 5 volume of Welding Society, and then FEMA. And then there is JIS, Japanese Industrial Standards. They are quite different, and they have their national pride or some such thing. JIS is a major publisher of standards in the world. And and one funny thing is in Middle East or in US or in one of the underdeveloped countries, there are consultants from Europe, there are consultants from USA, there are consultants from JIS. Now, unless the country in their contract insists on certain standards, the contractor follows their own standard. Then there is Australian standard and New Zealand standard, which is quite limited. Then standards by other organizations. There are other organizations as well. That is the FM Global. This is an US insurance company. It is so large. It covers the factories and storages and other establishments by insurance. Its fund position is enormous. So they have their own private standard. It's a private standard. Whoever wants to come under the umbrella of the US insurance company, FM Global, they have to follow their standards. It is not contradictory to Euro or to ANSI or to ISO. It is their own standard, particularly for the insurance purpose. And then there is the SDGs. All of you know SDG. There are now 17 SDGs, Sustainable Development Goals. Now, whole of our United Nations, the various branches of the United Nations, the various countries who has subscribed to the Sustainable Development Goals, like we are one of the countries who has subscribed, so they have to follow this. Can you see this 1, 2, 3, 4, 5? This 17 standards. These are called SDGs. Then, since we are all engineers and we we have cost about 20 minutes, we have got 10 minutes more on this subject. So we will take a little bit more time on limits, fits, and tolerances, and then surface finish. That will cover our course. Then we'll come to some other subjects which are very dear to me and which I go on giving presentations. Now, limits means why we need. You can see a bearing. It's a double roller, spherical roller, self-aligning bearing with a seal, loop seal. So this is fitted to a shaft here. This is fitted to a shaft here. So in the bearing company manufactures as per their own standard, and that standard is printed in their book. The standard is printed in their book. And when you, and their books, escape books and fact books are enormous with 7,700 pages. And they give you what kind of feed you want. Outer rotating, inner rotating, slide feed, a drive feed, hydraulic drive feed, manual push feed, interference feed, all kinds of things. And they suggest in their tables what kind of feed you can choose. And we always follow escape table in our manufacturing standards, which has given us good dividend. So this is a bearing housing. It needs lots of tolerances in fitting, in the loop, in the loop cage, and this is a sectional view, this is an end view. This I want to read. This is quite important. The need for limits and fits for mechanical workpiece was brought about mainly by the inherent inaccuracy of manufacturing. When we manufacture, we can never reach the ideal dimension. No, never. Coupled with the fact that exactness of size was found to be not necessary also for most workpieces. It is found sufficient to manufacture a given workpiece so that its size lay within two permissible limits: the Achyut superior, Achyut inferior. The tolerances, this is given the variation in size acceptable in man. What is the total tolerance? I'll come deeply on you in few more slides. Similarly, where a specific fit condition is required between mating workpieces, it is necessary to ascribe an allowance, i.e. a deviation, either positive or negative, to the basic size to achieve the required fit, which could be clearance, interference, or transition. So you see the basic size, say I call it 25 millimeter. The shaft is 25 millimeter. I can never give a shaft by drawing, by polishing, by whatever, a dimension of 25 millimeter. There will be tolerance on it. And also all through the length of the shaft, maybe the shaft is 50 millimeter long, I cannot maintain the same tolerance. So there are various variations to this. We may not go through all this in our lecture today, but I will give you a glimpse of it. Let us see. This is Achyut superior. This is the hole. This is the hole. This is the hole. So what we can achieve is we give a tolerance. This is Achyut superior tolerance, Achyut inferior tolerance. This is the basic hole. It could be a little bit smaller. It could be a little bit larger. And there is a shaft basis system also, the same philosophy, but we don't work on shaft basis system. In the industry, mostly in Indian industry, a whole basis system is what? But when you come to a bearing, it is a shaft basis, since holes, the bearing is already manufactured. So this is the basic size. This is the basic size, as you can see, basic size. And the tolerance is always plus. It should be more and still more. So this is my zone of permissible limits. So it says this the basic size and actual size, etc. So see, if this is the whole can have a look like this. It can be here, it can be here, it can be here, anywhere. Whatever the designation, I call it H7, I call it H8, I call it F9, whatever. And the shaft can be like this. When the shaft can be like this basic size, it can be less than the basic size, it can be more than the basic size, like this. There are various grades using the alphabets, capital alphabets for hole and small alphabet for shaft, which gives the designation, and there are 16 grades of height tolerance. I'll come to it. So this is the upper deviation, lower deviation, and the zone of tolerance, etc. You can see that this is the baseline. So if my EI is this is all minus. ES is this, and this is deviation K. This is A to H. A to H is all minus. And K to ZC is all plus. The zone may be here or here. I'll show it in the later slides. And this is the whole from A to H. It is all plus, and from K to ZC capital, it is all minus. This is the tolerance chart. This is the basic size. So this is A, these are holes, A to H, JS is plus minus, and then all this. And then this is for the shaft. This A to H is all minus, JS is plus minus, and this is all plus. Like it shows here, like it shows here, like it shows here. All minus, transition, all fit, drive fit. Now, what is the tolerance? The what? Let us say we have a hole which is the basic dimension is 20.625 millimeter, and then I say plus minus 0.025. That means the shaft is acceptable to me provided its dimension is 20.650 or 20.600 at the lower side. Then it will be acceptable to me. And this is how things are done. We can't do a basic size which is positive. No. Here, my total tolerance is 0.05. 50 micron is my total tolerance. The concept of micron is 10 to the power minus 6 meter. 10 to the power minus 6 meter is a micron. 10 to the power minus 3 millimeter. Since a millimeter is 10 to the power minus 3 of a meter. Right. So, functional requirements of mating parts. What kind of fit? It's a dry fit. It's a bush. I permit the shaft to rotate smoothly with lubrication. The lubrication should not go out. If I make it too tight, the lubrication will go out. I've got few more minutes. So this is how we write in the assembly. 50H8. This is for the whole. 50F7 for the shaft. And the fit is called, if a 50F7 shaft is mating inside a 50H8 hole, we call it 50H8F7. That we note in the assembly, and this in the individual part drives. Same thing. This is a clearance fit. This is a transition fit, which I can make my transition here. I can make my transition here. I can make my transition here. I can make my interference here. Same thing. Very clear, I think. We cannot. These are a few fits, clearance fits, which are very common in the industry. You see, one never fixes fits with H6, H5 tolerance. We can't do it. We don't have the machine to do it. You see, H7, H6 will give me a precision fit, but a closed running fit H7, G6. If I don't have machines to do a G6 tolerance, I'll use any other grade. It is possible. If I don't have the machine, I'll use a higher grade to get my fitting. Then there are interference fit and transition fit. This is very clear. Hole basis system, very clear. And this is a shaft basis system. Hole we give a basic size, and then we play on the shaft dimensions. limits, fits and tolerances, various grades. Interference rate, we have to go very fast. Now, IT, international tolerance, there are 16 grades. There are, okay, from IT 1 to IT 18, there are 18 grades of basic sizes, which, we don't play in this area. This needs grinding. This needs special policing. This needs, it is almost, our slip gauges are of this grade. But in normal, our manufacturing field, we use these grades. But when you go to flame cutting, a hole with flame cut, we come in this range. So these are various international IT grades. And basic size, what is the magnitude of the IT grade at the basic size? I have to go faster. These are various formulas, how the code develops the fit sizes. Now, one more item in 1 or 2 minutes, surface finish. We need, other than the tolerance of dimension, we need the quality of the surface also. So there is a CLA value and envelope method. We follow the envelope method, the German system. This is the gauge. This is the pointer which we slide. But there are machines to do checking on the surface finish and what kind of tolerances, surface finish grades we can achieve in various kinds of machines. Only with lapping we can arrive at a tolerance grade of 3 microns, etc., etc. Surface finish chart. I have to go through the meaning of the symbols. The meaning of the symbols, surface texture. Oh, this is very important. Roughness number. We say the roughness number is 6.3 or 3.2, which comes to preferred number. I'll come later, but we don't say 5.1. That is not accepted. So I have consumed about 42 minutes. I believe 32 minutes, and I have finished the subject. You can later on ask me any question, sir. Any question. Without question, a presenter feels cheated. Any question is a good question. Nothing. If I have been able to convey my wishes, my presentation to you, that is fine. Then if I cannot convey, that is my failure. So we come to certain items, these items, which are very near to my heart and which I feel one has to use as an engineer. Preferred numbers. You see, you get 10 square root of 1 to 10, 20th square root of 20. So, and then we get, I have to take 1 hour to lecture on this subject. So I don't have that time. So I'll just say, we go by this. We go by this choice mostly. If you have to say you are making a shed for a factory, what should be the dimension of column to column? You can say 4 meter, you can say 5 meter, you can say 6.3 meter, you can say 8 meter. What is the beauty of it? You see, you make motors, you make electric motors. So if you say I'll make 1 kilowatt, 1.25, 1.6, etc., and say somebody needs, he can always multiply by 10, multiply by 100. Somebody needs 95 kilowatt. He can come to 90 kilowatt. If he goes to adjust 20, adjust 10, he can come to 80 kilowatt or 100 kilowatt. But if you find he will serve the best amount of customers if he makes if he making 100 kilowatt motors, 100 motors of 1 kilowatt each. Instead, if he reduces inventory to 11 numbers only, so this will be his choice. The second choice, this will be his choice. 11 numbers only for his motor, 1 to 10 kilowatt, or 11 numbers only 1 to 100 kilowatt for his motor. He will serve anybody within 6.25% of his needs at this level. and here within 12.5% of his needs. There is the IS on it, IS 1076, part 1, 2, and 3, giving the prefer. I use it very often in all my work, in all my design works and everywhere. Why do I start? I start with any of the preferred numbers. So next is the engineering drawing format. See, we have got, you all be knowing A0, A1, A2, A3, A4. Our books are all A4. Some of them are A4, A5. But then what is A0? A0 is 1 meter square. The area of the drawing is 1 meter square. Now, if you come, if any of this side is, if this side is this side by root over 2, then if you fold it, you always get the same ratio. So that way we have come with the equation that 841 by 1189, it gives 1 meter square area, and this is A0. You halve it, then that 1189 halved is become 594, and the other side remains 841. You have it, 841 becomes 420, and then like this. This is our, it is covered in IS SP26, and this is engineering drawings. There are few more ISS on engineering drawings, but this is the basic thing we must follow in all our documentations. It has to be either A4 or A5 or A3 or A2, like that. Otherwise, you cannot fold it. There are standards for folding, there are standards for everything. After all, racks are made. If you make a rack for a 12-inch or say 300 millimeter book, and if you go on filling up with only 200 high books, then it's a loss for the library. Now we'll come to information and documentation. There is a book, UDC, Universal Decimal Classifications. Any subject under the sun can be given a number. 621 is mechanical engineering. 624 is civil engineering. 624 is civil engineering. Like that. So this BS 1000, it's a very abridged version of UDC on all branches. You know, basic sciences are 5. It starts with 5, not with 6. Applied sciences starts with 6. Like that. Philosophies start with 1. Like that. So I may be wrong in my statement, but 5 and 6 I know. 5 is basic sciences and 6 is engineering sciences. And then you can go on increasing the number. I am sorry, this is again a half an hour lecture. I cannot do it now, but you have to be happy with it. Whoever is interested, you may look into it. And I follow this in all libraries. They follow some Dewey Decimal form or UDC form or some other form. In ISS, you will find UDC number printed already. Then we are coming to some fundamental maths. You see, Euler number, you are all scientists, you are all very learned people compared to me. So for me to tell you these things, but anyway, one has to remind sometimes. So this Euler number 2.71e, 2.718, and it has got peculiar magical properties. Then pi, people write poetry about it, 3.141, and people has gone mad. People has gone up to quite a few lakhs of decimal places, millions of decimal places on pi. And then golden ratio 1.618, and then prime numbers and root over -1 imaginary number. All our electrical engineer friends must be very happy with it, and our mathematicians also happy with it. So this is the Zurong Park. So now we come a few more interesting subjects. That is our knowledge base. This is Rhoda, the thinker, is sculpture. We have to think. I am requesting all my friends, colleagues who are listening this, kindly give some time every day to think what you are doing, why you are doing this. Think. Somebody told Professor Albert Einstein, what is your laboratory? He showed his head. And there is a passion. So we have to develop the passion. We must enjoy what we are doing. We must enjoy. This is from National Geographic, how your brain, this is various views. This is how our brain looks like. Please read. Gradually, with the advent of this terrible media, we have got no time to read, but to learn. If people can say, I can say certain, I can commit mistakes in my presentation, but when I write something, I publish a book that will be for eternity. So I have to be very careful what I am saying, and I check, recheck before I commit to printing. I like this book, Walter. I like quite a few books also. I like Timoshenko's books as well. I consider an engineer who has finished the 2 volume of Timoshenko Young Strength of Material. He is already a 50% engineer. Anyway, for the love of physics, I like this. And there are lectures, 801 series. This, MIT has given all lectures on the internet. So your Professor Walter Levin's lecture in 8.01 and 8.02 in physics, they are marvelous. I like them. This happens to be where I'm sitting, my place of work. This is Ray Kurzweil. He is saying singularity is near. Marvin Minsky, artificial intelligence. And Ray Kurzweil he said how to create a mind. He has written a book on it, how to create a mind. He is creating a mind. He says, the kid who is born, he has got the synapses, but he doesn't have the knowledge base. He is gathering knowledge base every day, millions and millions. So also I create a quantum computer with 53 qubits. I don't know when we'll go to 100 qubits. Anyway, and then we go on teaching it. It will have thinking power. Anyway, that's a very debatable thing. And then these are our engineering heritage. The pyramids, Machu Picchu, Stonehenge, Harappa, Nalanda, our Taj Mahal, Blue Mosque, Isfahan, Iran, Burj Khalifa. This, unfortunately, we have got only one earth. We do not have more than one earth. So let us not destroy it. You use it with care. You use it with care so that we preserve it. We are on the point of, I don't know, destroying it almost. Learning from nature. You see, it is the Iskar, Fibonacci numbers, fractals. Fractals in nature. This is common succulent. In Geneva, in United Nations office, there is a garden, about 30-acre garden. They have got Europe, America, like that, various, where they have printed, where they have put plants from those areas. And there is a garden, Jardin garden for mathematics. There is a garden for mathematics as well. So I had a garden like this in North 24 Parganas, sure. But it has been taken away from my hand. That's another story. That's our West Bengal. Now, anyway, at least I am doing with garden on my roof. And it is giving me plenty of fruits and vegetables. And I can distribute. Thank you very much. How do I go out?
Yeah. Thank you, Professor Ghosh, for a nice lecture. And now
how do I get in? How do I get in, sir?
How do you get in? You can stop presenting.
Yeah. Okay. That's it. Stop presenting. Yeah, I got it.
Yes,
Thank you very much.
We can see you now.
Thank you very much.
On screen. So now the floor is open for questions.
Can I say something, sir? Professor Ananta Suresh. Any question, you can ask me any question. I have not been able to give the lecture in a due way, but your question is never unintelligent. You can ask me anything.
Okay, sure. I think Professor Ashok Kumar Pandey has raised his hands. Ashok, please unmute and ask.
Yeah, Professor Ghosh, thank you. It was really very enriching to go through all these standards. And so just wanted to know, you mentioned that Japanese standards are more dense than all others. And why they still follow that? And is the standards that we follow and rest of the world are anyway different than the standards that they follow?
Sir, I'll answer it like this. When Japan is selling to other people, they have to follow the ISO. No way, otherwise they cannot sell. But I had been to Japan to find out the people who does so beautiful aesthetics and does harikiri as well. They do harikiri.
Right.
What is civilization? So, I mean, after all, visiting for a month or this does not solve the problem. But to me, Japanese society is something very curious. I have the privilege of going to about 80 countries in the world. But the Japanese people keep me guessing always, honestly. And their codes, for their internal use, their codes are somewhat different. And they're quite steep.
Okay, thank you.
Sir, I have a question. Actually, I am from electrical engineering background. And we see most of the electrical engineering background, the textbooks, everything mention of IEEE standards. So for Wi-Fi, for Zigbee, for all the communication protocols, it's all about IEEE standards. So where does IEEE standard come in and fit in? Does it come in the ISO? Does it come into the Euro standards? From where is that derived out?
As I said, madam, that there are various associations. They are free to have their IEEE is a very, very strong organization. And they are mostly electrical and communication. I don't think ISO or Euro touches upon communication much. Not much. The communication is really left to IEEE. There are certain specific areas like paints and other things. They are covered by separate societies. Like the American, American ANSI their national standard, but they have got ASTM, ASM, and then so many FEMA and so many things. They are independent people. They are independently doing. IEEE is a very, very honored organization in the world, and their communications, whether I don't know their relation with ISO. I don't know whether ISO accepts IEEE standards and ISO standards and all these things. That, madam, I am not very sure of.
Okay, thank you.
Are there other questions? Yeah, Professor Ghosh, I have a question.
Yes.
Whenever a standard is developed, who pays for it? Who pays for the process? There is a lot of process in developing a standard. All that work, who funds it? Industry does it, or government does it, or?
There is a two-part answer to it. One part is, firstly, IES, when it was created, it was not a totally government organization. There is an office in Delhi, Manak Bhavan and all that, but it was a semi-government organization. But after this 86 BSI, it is an absolutely government-owned organization. And how they fund it, I'll tell you this story in a moment. Government first staff salary, the building annual maintenance cost and all that. That is government, paid by the government of India. But IS has got a very lucrative source of income. That is, if you want to stamp your product, that okay, the specs I produce is for IS so and so. Okay, the bolts I produce is as per IS 3134. The bolt I produce is as IS 3133. And or somebody says the wire ropes I produced is as IP 2266. So those to maintain the branding of IS in their product, you must be seeing that a lot of companies advertise this is as per IS and we follow IS standards. So to maintain the branding, people have to pay in lakhs. Large companies, they have to pay in lakhs, and 4 times a year the dedicated inspectors will go to the factory, they will do the testing, they will see that this is being done as per Indian standards and that kind of thing. So their source of money is really all the industry in this country and outside also. If somebody wants to follow IS like Ceylon, Bangladesh and others, sometimes Pakistan, our Pakistani money was being printed in India. Anyway, so that kind of thing, people pay lots of money. So IS got no fund crunch. They are floating on front.
Oh, I see. Wonderful. So if anybody wants to develop a standard, they can seek funding from them or they do all the work?
No. They have to join one of the SSCs of IS.
Okay.
They can make a standard in their company, but they have to submit it to IS. And if it is to be accepted by IS, it has to go through the overall. And that takes 5 years to 12 years. And one more thing I have forgotten to tell you, sir. Don't make a standard very, very rigid. Right. That will take away the the innovative part of it. People will come out. I make my this thing as a one way, but there will be some other company do it some other way. So if I make a standard on air conditioning operation switches, it should be a very open so that it does not stop the idea of development.
Mm-hmm. Right. Thank you. Let's see if there are other questions. Otherwise, I have one more question. Anybody else has questions?
Yes, sir. I'm Ashfaq here.
Yes, Ashfaq. Yeah.
Sir, I have a question to Professor Ghosh. Sir, do you think standards can be a one semester course in any of the mother branches like mechanical, electrical, electronics? Let a student get aware of the important standards that they have to follow after passing the graduation level.
I don't think it should be a course, but definitely, you see, like a lecture like this, some of the professors who are aware of the standards, they can always take special classes on making the students aware of the standards. But for a course, after all, I had the bad privilege of constructing course structures in engineering. To limit our subjects in 4 years, 3 years, 5 years is a headache for us. So introducing one new subject in the course, Professor Ananta Suresh is laughing. I think, sir, he will agree with me that the course already we have, it is so difficult to put it in the 4-year format. And the 4th year, people will go on giving interview only. No course, sir. We don't attend classes no more. Enough has been given. I have already got a salary of 1 lakh per month or 10 lakhs per month as the case is. So I don't need any more course in 4th year. So it is only limited to 3 years. Sir, don't introduce any more subject.
Yeah, just a follow-up to Ashfaq's question. By understanding the standards, does it make an engineer more innovative, more efficient?
Honestly, sir, an engineer to work in any engineering firm or any engineering atmosphere, he has to understand standards. Otherwise, he can't deliver anything. He cannot deliver it. He cannot even draw a line. There are 10 qualities of line in a drawing. So he cannot even draw. How he will convey his thoughts? He'll go on talking to every operator that this is what I'm thinking on the job. He has to transfer his thoughts, his ingenious ideas only through a drawing. And maybe a 2-3 page booklet as well, or a note in the drawing. So he has to learn the language. He has to learn the idea of standardization. That's my answer. Okay. I don't know whether it is satisfied.
So, yeah, students who go to the industry to work, they will have to learn about standards as part of their industry job, right? Because they are not taught in the universities, they have to learn it on the job.
I will answer it from the industry side, sir. All industry, when they take a student for first 2 years, whatever is the salary, the industry considers that it is my duty to train them up, to come them what is the workshop practice, what is the forging. I mean, you can teach your boy, your mechanical students what is forging, but he has to stand in front of a furnace and see steel at 1400 or 1800 coming out of the furnace to know what is forging. So all engineers, all industries consider that it is their duty to train up boys for at least first 2 years after they graduate from their courses. And then that industry, a serious industry in this country, not fatka, serious industry in this country, they consider it very seriously. Since I happen to be so many interview boards, people pay me money to sit in the interview board and take people. And we know the attitude of the management. You know, Hindustan Lever is called the company who produces managing directors of all Indian organizations. That's their name. That's their reputation.
Yeah, right. Thank you.
Any other questions?
Any other questions?
I have a personal question. Like, we are coming from IEEE now, and we are doing this whole webinar under IEEE. I wanted to ask suggestion from Professor Achyut. How can IEEE contribute towards Indian standards, and how we can participate in formulating standards?
Madam, I will say like this. A standard is a very personal affair. There are 20 people in a SSC. So when you feel that you have got certain things to contribute, you know certain things is on a subject which there is no standard, or there is a standard which needs lots of improvement, you should write to the Indian Standard, Bureau of Indian Standards, that these are my ideas about this. You kindly permit me to join the SSC, and I'll work on it. And that's how it takes place in various standards. In our code committee, in our code committees, there are various kind of people. People like me, who is 82 years full, and young people like 20, young professors like 30 years, 34 years, but they contribute a lot. They have got brilliant ideas, and it is our job not to kill those brilliant ideas, but to see that they are given air and given chance to success.
Thank you.
Thank you.
Are you satisfied with my answer?
Yeah. We were actually from many years we are thinking in IEEE that we should do some activity, a workshop, or basically create awareness to people who think they can contribute towards standard creation. So the question was more towards that, like how we can initiate some activity in that space.
Madam, actually, an organization like IEEE joining, I am not sure whether they accept like that. But individual members can always contribute.
Like IEEE is a professional body. IEEE is a professional body like IEEE, but of course, multiple full scale, larger and more well accepted. So they have been able to evolve and create standards. So eventually, like, there are professional bodies which can have a say, but we do not know how to start. So it was all around that. That's how. Yeah. There was someone else who wanted to ask a question. Please go ahead.
You can visit Lal Bahadur Shastri Marg, this Niyamok Bhavan. You can visit the IS Manak Bhavan. You can visit, you can have a talk with them, with the director, with the director general, you can have a discussion. You can have, after all, your standing is enormous. You are coming from the institution which is known all over the country and all over the world. So you can always approach them, sir, madam.
Thank you.
Sir, I have one small question. I am Sudhakar here.
Yes, Sudhakar.
All the standards that were brought in actually over whole decades, they're all based on the scientific principles. And there are so many factors that are considered in the standards. Now, with the AML coming into the existence of the so many designs and practices, whether say those particular factors can be revised and say those standards can be revised. So those particular standards, is there any plan to revise them with reference to AML, sir?
I'll tell you, sir, let us take the standard for. Every standard, by the way, is continuously being revised. The SSC committees are not just disbanded after the standard is published. Most of the standards are third edition. I can tell you 4137 about crane. That second edition is going on. In people concerned, they may sit together. They feel that while we are giving sentences to our thought process, then all sentences may not be matching. All paragraphs may not be matching. So while working, we find certain difficulty in writing. So people from the field, people from the organizations, they go on issuing letters to IS that this clause in IS so and so is contrary to our thought process, contrary to our process of manufacturing. So we need a revision. So the SSC committee will sit on it. Sometimes they issue revision papers, only small printed revisions, or they revise the whole and they change the date of publication with the revision date. It is a continuous process. Standards are a continuous process. You cannot limit it. There will be development happening all over the world.
No, sir, I agree with you. But what I'm saying is all the standards are being revised. The consideration of AML techniques into the procedures, whether has been considered so far.
What is that technique, sir? Can you please repeat it?
Artificial intelligence and machine learning techniques.
Oh, yes, that's a subject. AIML, artificial intelligence, and yes, they are coming into the field. But see, in the making of a soap, we are concerned about the quality of the soap. How much alkali, how much saint, and this. The making, in that AIML do not come in. In the making of a soap, maybe AIML may come in. But that standard is very specific in how much area it is trying to cover. It is mostly from the user's end. Mostly for the user's end. How convenient it will be to the user or to the manufacturer who is selling the product to the user in having this standard. So machine learning and all these things, these so many development and working that people use in their production process, in their designing process and all that. But there is never any conflict with any standard, I don't think.
Sir, now AML is spreading in so many design areas. Unless we have standards in AML, how exactly really these technological developments will be absorbed in various design areas? That is the main challenge, no, sir.
To be honest, sir, I am 82 years old. My knowledge of AML is so less, so little. Only I have read few books and all that. But I am not competent to comment on this.
Sir, I want to just add one sentence here. It happened to I present one of the standard organization meeting in absence of my reporting officer. Their earth moving department, they are making standard having AIML technique for control of the equipments. So that is already being consideration. So wherever possible, this AIML they are including into the standards.
Fine, you got an answer, sir. Thank you very much, sir, for kindly giving the answer.
So are there other questions? Rather, I think I have one more question, Professor Ghosh. Your seminar was very informative. I learned a lot of things. One of them is this Renard series, preferred numbers. What is the basis for that? I was not aware of those things at all.
Root over 10. Any root of 10, root of 5, 5th root of 10, 10th root of 10, 20th root of 10, 40th root of 10. Shall I go into a little bit more detail in this?
Yeah, you can. But what is the basis? What is special about root of 10, root of 20? Why is that preferred? Why is that number preferred? What is the basis?
The whole idea is you solve maximum number of customers' demand with minimum amount of deviation from his demand. That is the crux of the matter. Okay. So let me say, an asbestos manufacturing company, no, asbestos. Tin manufacturing company is making tin. They are making corrugated, long corrugated, painted, all these things. But what will be the length? Will they sell it 1 meter? Will they sell it 5 meter? Will they sell it 30 meter? No. They will go by standard. They have got a standard. When I say R-20, it is either coming to a very reasonable size. It could be 4 meter, it could be 4.5 meter, it could be 5 meter, it could be 5.6 meter, it could be 6.3 meter, it could be 7.1 meter, like that. You select an area, or you select every third of R-20 for your product size. You make a soap. What should be this size? 100 millimeter by 16 millimeter. I don't say 15 millimeter. I say 16 millimeter. Since that is an IS preferred number. And then 50 millimeter. So I say 50, 100 by 16. That's my soap size. How do I come to it? Well, you have to put it in a stack. You have to put it in a rack. You have to put it inside crater. You have to put it in containers. So once you use some of these preferred number sizes, you will find your efficiency of packing, your efficiency of transport, your efficiency of usage, your efficiency of stack space. It will go improve like anything. Yeah. Have I been able to convey my idea, sir?
Yeah, that is correct. But I'm saying that how did it evolve? I think it was suggested by somebody called Renard.
Oh yes, it's a cavalry man.
Yeah, what was the basis? Why did he come up with square root of 10, 20 like that? Could have been cube root, could have been square of a number, all kinds of things, right? Why was this particular thing chosen?
1857 or some such time. Yeah. The idea of a cube root must have been very foreign to him. Square root, square root is, well, either is you increase by a arithmetical progression, or you use a geometrical progression. So obviously arithmetical progression means lot of items. 1 to, if you from 1 to 100, you get 100 sizes by arithmetic. Okay, by 5 millimeter, 5. Okay, 5 arithmetic 5. 1, 5, 10, 15. I'll come 60, 65, 70. Let us take the area of 60, 65, 70. In this area, if somebody wants 62, you are giving him within 12%, not within a fixed percent. But if he goes by a geometrical progression, whatever is demand, you are always giving him within a fixed percentage of his demand. Whether it is 6.25% or 12.5% or 25%, depends on whether you have chosen R-5, R-10 or -20. I mean, sir, may I suggest that you go through this IS 1076 a little bit, you get it, and I am a bad teacher.
No, it's very
explain it to you.
Right. This is the first time I came across this, so I have to read and understand. And thank you very much for clarifying.
I am using, your paper. This paper. This is preferred number size.
Yes, yes, yeah.
So area, paper number area, that kind of thing. I mean, everything is there in paper numbers.
Right. Yeah.
Any
Sure.
other questions, sir?
Yeah. Any other questions from the audience? Okay.
One last question. Was
Yeah.
it?
Ashok, go ahead.
Professor Ghosh, you were mentioning about mathematical garden. So, other than like, what are the different types of the mathematicians who really try to work the different patterns and also look at such kind of patterns in the plants. So you said that you are maintaining it, and
Yes.
can you please comment some more?
Yes. Professor Ananta Suresh, if you arrange for another lecture where I'll discuss only on this subject,
Okay.
it is possible. You know, nature, we all learn from nature. Everything, whatever things we create. Have you ever thought of these blind things which create soil mound, 2 meter high, 3 meter high soil mound? So this is what I am suggesting, sir. Nature, we copy nature. And you see, have you thought of a coconut tree, sir? A coconut tree. We all know a coconut tree. When we create a structure of light carrying poles, light poles, the foundation, the foundation, the slenderness ratio, everything is already been created by a coconut tree. If we copy that, we'll be a better light stand than. You see, you have seen this butterfly, this flying the mosquito. You think of a mosquito. Oh, what a beautiful structure, how it can fly, and how you think of a bird or anything. You think of a bird, how beautiful it is flying, doing that job, and which requires for us to fly. We are hardly flying 120 years only, and the bird is flying for 10 million years. The efficiency of the thing. So when we are trying to do things, if we look around us and look at the nature, then you now let us say, we, for our body, I, human being, Homo sapien, for my body, I am using so many medicines to maintain my body. Now tell me, in a forest, there is a living plant. Who is giving his medicine to maintain? It cannot fly away even. When I am attacked, I fly away, I go away. I have got 2 legs. But that plant cannot even go away. It has to stand there and take the attack on its legs, and still it is standing. So its defense mechanism is much better than mine. Have I been able to convey my thought process?
Yes, Professor. Yeah, thank you.
Yeah. For the audience, I just posted a link to Professor Ghosh's lecture. That was very nice. I recommend it to you highly. I put that in the chat box with the link. It was given at IAEST Shipboard, and there's part of the centenary lecture series. That's when I came to know about Professor Ghosh. I put the link for those of you who want to watch it. Are there any other questions?
So the link which you have sent, it is showing, sorry, you do not have permission to access the requested URL.
Oh, really? Okay.
I think you have to talk to Bidut or somebody.
Otherwise, what I'll do is I will paste the link where you can find the organizers also. Centenary lectures, all the lectures are there. Professor Ghosh is the second lecture. So maybe there is something that happened, which they will fix it. But you can go here and then see. Yeah. Thanks, Sunil, for checking immediately.
Sir. Yeah, thank you.
Yeah.
I will also be
Professor
uploading
Ghosh?
this lecture on our YouTube channel, IEEE, and I will share that link with everyone.
Yeah. Thank you.
Veda, I wish some of my friends in USA, I can find one of my friends from USA, Mr. B.K. Mitra. But anyway, I thank him for the night. Anyway, so can you please send it to me also? So
Yes, I will definitely send it to you once I upload it.
So Ashok, Professor Ananta Suresh, Ashok Mollik, he has got something to do now, but he has told me to get the link somehow.
Yes, we'll send it to him as well.
Amitabh Ghosh has asked me to send the link.
Yes.
Amitabh will be in Texas today, so
Right.
it is not good time. 2:30 in night.
Yes. Yeah. Right.
Okay.
Professor Anand Suresh, you can post your lecture link also, sir.
Sorry?
Your lecture link also you can post, sir.
That was a wonderful.
Yeah, it is there. It is there on that.
That was a wonderful lecture. I enjoyed it. I enjoyed Ananta Suresh's lecture.
Thank you, Professor.
And my friend Amitabh Ghosh, he's junior to me by 1 year, the IIT director Kharagpur. He was praising Ananta Suresh during the lecture. He was saying, "My God, I got Ananta Suresh. Even I am in USA, I have to attend it," like that kind of thing.
Thank you, Professor. Let's thank Professor Ghosh for a wonderful talk and then interaction. Thank you, Professor. It is really nice that we learned a lot about standards, and your last slides were really wonderful. Asking everybody to read. That's a good message. Read from the books.
Yes.
My two granddaughters, you see, Ananta Suresh, it is very difficult for me. I have got a library of 5,000 books in my house where I am living. I am an old school man, 82 years old. So I have got a library with 5,000 books. I can hardly make them touch a single book. What do I do? It's a dilemma with me. Ma, Veda, you are laughing, Ma, but it's a great problem for me.
I agree, because I have the same problem with my son, so I can understand the next generation doesn't want to touch books. I agree on that.
So painful for me. I tell them, how do you learn to talk? How do you learn your culture? But anyway, they will have this thing. Yeah.
Exactly. Yes.
They listen and watch and learn and browse. Right? Yeah.
Reading books has become a rare thing now, and it's very unfortunate.
But I still do. I go on. I read something every day.
Yeah.
So,
books are always your best friend. I agree.
Best friend.
Yes.
Best friend. Amitabh Ghosh. I mean, the writer Amitabh Ghosh, not my friend Amitabh. I love his books. Anyway, so many writers are there. So I must tell ISSS that I have enjoyed such a learned, you always talk, but learned, very, very learned professors and teachers and students listening to you. You get seldom opportunity to such a learned listeners. So I must thank them for giving me the chance to present my presentation. And I find Ghosh also. Ghosh is one of our standards organizations, Steel Standards Institute. Ghosh is there. Anyway, so I must say thank you very much. And anything which Pandey Saab or Ananta Suresh or Veda orders me to do for any future lecture or anything, I am available.
Thank you so much. We are really obliged. It was a wonderful lecture.
Yeah.
Thank you.
Thank you, Professor. Yeah.
Bye.